Okay, everyone. Last but not least, literal equations. These can be really intimidating. I just want to say that the tools you need to solve these are the exact same tools we've been using. So the trick is just one of my big ones, right? See the simpler problem in the mess. So like, for example, this first one, this really is just a linear equation, as scary as it looks. So always remember, focus on your variable. T sub I is what I'm supposed to be solving for. So literal equations are basically formulas that you're solving for a specific variable. Okay, so if we want to isolate T sub I, we want to think about what's happening to it. The subtraction is always kind of funny. I guess really what's happening here is you're multiplying by -1 and then you're adding T sub F. That's how I would say it to myself if I'm subtracting the variable I'm solving for. And then the last thing you're doing is just a whole bunch of multiply. It looks really weird, but that's just multiplying by SH and by M. And I'll just say that this, I think, is a chemistry formula. I don't promise, but SH could be its own single variable. It might not mean S times H. We don't do that a lot in math, but you will see that a lot in sciences, and it's totally valid. For us, it doesn't really matter whether it's S times H or just SH, but that would be a reason why the parentheses are the way they are, to show that that's actually a single variable. Okay, so if the last thing happening is multiplying by a whole bunch of mass, I would say the first thing we need to do is divide by that mass. SHM. And I would be fine if you drop the parentheses. The reason I'm keeping them is probably if they were in there, there was a reason. So I'm just going to hang on to them for now. So I get Q over SH times M is equal to T sub F minus T sub I. So I think we used a little bit of that subscripting notation before. It's probably an initial and a final temperature or time, something like that. I would guess temperature, but again, it doesn't really matter. If you can pick up little bits of meaning, that's great. But the point for this class is just that whether we know what SH is or not, we still know how to manipulate the formula. You can learn the meanings in your science classes for some of these. Okay, second to the last thing was adding T sub F, so I'm going to go ahead and subtract it. And I get Q over SH times M minus T sub F is equal to negative T sub I. And then the last thing would be to divide by -1 or multiply. It's all the same thing, right? We're just trying to eliminate the sign. So just because it fits better on my screen, I'm going to write that as multiply by -1. And I'll get negative Q over SH times M plus T sub F, make sure you distribute that, is equal to T sub I. And that's my final answer. I'm not really worried about you getting a common denominator and adding those together. I'm really just worried about isolating the variable. So I would say typically my stickler rules for almost everything are going to be no fractions and fractions, no negative exponents. So if you get those things, keep working. Otherwise, I'm not really that worried about making the single fraction. If I want that, I'll tell you, but not generally the point. If you're ever not sure, just ask. I'm happy to tell you. I try to be really clear, but I'm sure sometimes I miss it. Okay, so they look really bad. Hopefully not as bad as they look to solve. Next one, really big, ugly looking formula, P plus N squared A over V squared, that whole quantity multiplied by the quantity V minus NB is equal to nRT, and we're supposed to be solving for P. So again, really key is going to be keeping an eye on that variable all the way through and thinking about what's happening. Okay, so first thing we would do to P is the addition. I would say order of operations says we'd also do that subtraction right away. But if we're listing what's happening to P, first we would add that mass, and then the second thing we do is this multiplication, and that's actually it. So as bad as this looks, we should be able to work our way out of it in 2 steps. So again, seeing the simpler problem in the mass, it can be challenging, but we're just going to keep practicing. So if I want to get rid of the multiplication, I'm going to use division. And it's totally valid to divide that entire factor out. If all of it's attached by multiplication, all of it gets removed with division. Okay, so P plus n squared A over V squared equals nRT over V minus NV. The only other thing I had to do was detach that n squared A over V squared, and as scary as that looks, it's a single term, so I just move it all at once. It's all attached by addition, so I can remove it all with subtraction. And I end up with, see if I can squish it in here, P equals nRT over V minus NB minus n squared A over V squared. And again, I'm not really worried about whether you make that a single fraction or not. If OneApp is being picky about that, let me know. But that's a completely acceptable answer right there. I like it. P is isolated, no fractions in fractions, no negative exponents. Okay, let's keep going. I wanted to get you good variety because I know these can be really intimidating and give people lots of anxiety. So solve for W. What's being done to W is first a division and then a square root. So again, it looks really messy, but there's only two things to get rid of. So the square root's going to be the first thing to go. We would get rid of that by squaring both sides. So I'm going to get t squared over 25 pi squared. And I would say if you have extra parentheses, get rid of those. So some simplification is good, but I'm not really worried about getting common denominators and adding fractions. W over 15 is all that's left on the right-hand side. So to get rid of the 15, since we're dividing by 15, we would multiply to get rid of it. We have to do it to both sides. So we're just going to have a W left on the right-hand side. I am going to do a little reducing ahead of time. I see that I can cancel a 5 out top and bottom. So I'm going to get 3t squared over 5 pi squared. And that's my answer. That's great. So just like the problem was messy, the answers are generally messy, and that's completely fine. Okay, let's see. One with a cube root. So we're solving for t. That's a little tricky because t's in the denominator. So somewhere along the way, we're going to have to get t out of the denominator. I would say that's the first thing going on is that division. Let's see. And then, so again, focusing on t, it's really easy to get distracted and look at a. So I was starting to think about that multiplication, but really I don't need to separate 3 and a. I just need to separate the t from the 3a. So the second thing happening to t is that it's getting cube rooted. And the last thing is that we're adding 2. So first thing, I'm going to subtract 2. And I get r minus 2. I don't need parentheses really yet. Is equal to the cube root of 3a over t. So again, focusing on t, the next thing I have to get rid of is the cube root, so I will cube both sides. Cubing and cube rooting are inverse operations. And now I have 3a over t. And this is where rationals are a little weird when you're solving for something in the denominator. How do we eliminate that division by t? We multiply both sides by t. But it's kind of funny because it makes a new problem for us to deal with, but it's still a step in the right direction. So it's going to cancel t, and we're going to have t times r minus 2 parentheses, cubed equals 3a. Okay, so a little reevaluate step has to happen after you get a variable out of the denominator. Now what's happening is we have t multiplied by a big chunk. So the only thing we have left to do is detach that, and to detach it we'll use division. And you can divide out that entire chunk. If the whole thing's attached by multiplication, the whole thing can be detached using division. 3a over r minus 2 cubed, and that is my answer. So again, messy problems, messy answers, but it's trying to spot that simpler work that we've been doing within the mess. All right, very last one, solve for b. Okay, so there's my b. What's being done to b? First would be exponents, since I don't have any parentheses, and then second would be addition. So once again, they look really messy. There's all this stuff going on, but if you can focus on your variable, this is really just a two-step process. So the first thing I'm going to do is get rid of the 16a squared since it was attached by addition. I'm going to remove it using subtraction. So b squared is equal to 9c squared minus 16a squared. And keep thinking like terms, because that's a c squared and an a squared. There's no way to combine it, so you'll just write it like that. The next thing I need to do is get rid of the square. To do that, I would have to use square roots. Really train yourself. This is another one of those memorized things. You have to, when you introduce a square root, you have to include that plus or minus, because for any number that you're trying to get by squaring, there should be a positive and a negative option. The exception would be that you can't get a negative number by squaring, but otherwise you should have a positive or a negative number that you can square to get whatever positive number you're looking for. Sometimes a problem like this will say assume everything is positive, and in that case you can leave off the plus or minus, but other than that you would always include both possibilities. Okay, so hopefully that gets you started. I want you to get some practice with all these types in this section, and then in the next section we'll work on all three of them again, a little bit messier, and then in the next section we'll do all three again, all 3, 4, 5, I don't know, a whole bunch of them, again a little bit messier. So we'll just keep building and coming back to these kind of like we did with chapter 1 and chapter 2. So if at first it feels really crazy, stick with me, really work at it, we'll see it again, and hopefully it'll start to get really comfortable. Thanks for watching.